let's review about linear equations, some basic things. And in this lesson, the focus is on the standard form. In the standard form, this is what it needs to look like. Actually, this is what it needs to look like. This is the correct order. Okay, so I'm going to do this as, think about the fact that the AX is first, and then second is the BY. On the other side is the constant. And it must be in that order. The X first, then the Y, and on the other side, the constant. Okay. So remember that A is the coefficient of the X, B is the coefficient of the Y, and then the C is separated from them. So the correct order is one of the ways, one of the rules that you need to have standard form right. The next one is that the A, B, and C have to be integers. That means they're not decimals and they're not fractions. And the A cannot be negative. And the math way of showing that is to say it's greater than or equal to 0. So if this had been, let's say we had negative 4x plus 9y is equal to 12. Now let's not use 12 because that's reducible. Let's say 11. If we had this, we would have to multiply both sides by a negative 1 or divide both sides by a negative 1 so that we would get 4x minus 9y is equal to negative 11. That's standard form. This one is not standard form. This one is standard form. Well, let's take this one here and write it in standard form. So what we want to do is we want to get it into ax plus by equals c. So we have a couple of things we can do and two ways we can do it. We need to move this x term to the other side, but this has a fraction in it. In my opinion, it's easiest to simply first multiply both sides by the denominator to get rid of it. So I'm going to multiply both sides by a 5. And that means we're going to have 5y is equal to 4x plus 60. Notice that that 5 is to both things here. That's important not to forget that. Then we're going to subtract the 4x on both sides. And because we have to have the correct order with the x term first, we will put negative 4x equal, oh, not equal, because it's plus the 5y equals 60. And now we can see that we have this pesky little negative here. We have to get rid of it. So we'll multiply both sides by a negative 1. And that gives us the answer of 4x minus 5y is equal to negative 60. All right. We'll round it like that. Cool. Now, notice the places of error. One of the places that people can make an error is they change this sign, but they don't change that one. Okay. Another place that they sometimes make an error is they do this and they do 5y minus 4x equals 60. And temporarily that could be okay as long as you end up putting the 4x in front, but it's still not a good idea because people tend to forget to do that. All right. Let's do another one here in standard form. I'm going to do the same thing. I'm first going to multiply both sides by 9, and I get 9y equals 8x minus 2. Oops, I just made a mistake, and I did it on purpose. And what I was supposed to do was multiply both sides by 9, and that means I would multiply 9 into both of those things. So it's not a 2, it's an 18. Right, now we can proceed. We'll move the 8x to both sides, negative, subtract 8x here and here. Negative 8x plus 9y is equal to negative 18. And now we'll multiply both sides by a negative 1. And that's how we'll get 8x minus 9y is equal to 18. Let's have it cooperate here. didn't really want me to put the T in there. Well, let's force it to do it. Get that dot out of there. Much better. All right, so 8x minus 9y is equal to 18 is the same as y equals 8 over 9x minus 2. Now, next we're going to look at the intercepts. The intercepts are the places where a line passes on the x-axis. So I'm going to show an example here for this first one. Let's say we were down here. Well, let's say here and here. This is our x-intercept. This is our y-intercept. And we know that for the x-intercept, the y value has to be a 0, and for the y-intercept, the x value has to be a 0. So what I'm going to do now is I'm going to put the zeros. I think the best way to do this is first for the x-intercept. I'm going to show it. Whoop. That means that the y is equal to 0. We have this type of thing. And so what we're going to do is put a 0 in for the y. So it's going to be 4x minus 3 times 0 equals 15. So we get 4x equals 15, or x equals 3.75, and that's the y-intercept. All right, so over here, that's 3.75 and 0. Now we're going to do it where we're going to put the 0 as the x, and the y is the one we need, which is the y-intercept. So in this case, I'm still going to do that same thing, except now that's going to go in place of the x. And so 4 times 0, oops, I need to take that equal sign out because that's not what I need. So that's 4 times 0 minus 3y is equal to 15. Negative 3y equals 15. Divide by negative 3, and we get a negative 5. So that tells us when the x is 0, the y is negative 5. So about there on that point. Okay, so I want to put that one in red. There. So the x-intercept is 3.75 and the y-intercept is negative 5. The points where they are is this coordinate point, but the x-intercepts themselves are just the number with the x and y there. All right, now let's do that with this one. Go ahead and stop the recording and or the video and do it yourself, and then come back to it when you're done, and I'll start talking again in a few seconds. All right, that's enough time. If you just paused it and came back, you've had a longer time. You can use it. So what I'm going to do next, okay, this first one, I'm going to make it when the x is 0. Oops, no, actually, I don't really want to do that. I want it so that the x's are like over here and the y's over here. So that means I want the y to be 0. Over here, I want the x to be 0. So that means I'm going to put that as 8x minus 5 times 0 equals 36. 8x equals 36. Right? X equals 4.5. So it would give us the point 4.5 and 0, or it can just be find the intercept. And then the next one will make the x 0. And so we get negative 5y equals 36. And when we divide by negative 5 on both sides, we get y equals negative 7.2. That's the y-intercept, just like this is the x-intercept. And that would give us a point of 0, negative 7.2 if we wish to use it. But this is simply y equals negative 72 is the y-intercept, x equals 4.5 is the x-intercept. I should do that over here with them. Now let's think about what makes them linear and non-linear. The most basic thing that makes them linear is if you have exponents of 1 for both the y and the x. That's what you look for. If it's any other type of exponent, it's nonlinear. This one, we have an exponent of 2. Well, that happens to be a parabola shape. This one, you have to now learn that a square root is the same as the denominator of a fraction if it's an exponent. So here it is an exponent. We have x to the 1/2, but 1/2 is not 1. So exponents must be 1. So in the next one, oh, notice this. These are the same. There's just two ways of showing the exact same thing. Now over here, this is a different lesson that you can take a variable from the bottom, from a numerator, and you can bring it up to the top. When you do that, you have to change the exponent, because this one here has an exponent of 1. But when you bring it up to the top, you change the sign, so it's now y equals x to the -1. And that -1 is not a positive 1, therefore we're going to stop right there with it. These are graphed differently too, because that one, when it's graphed, is going to be something like that. Differently, of course, but something like that. The square root ones are all ones that look like that. Okay, and since the 1/2 is the square root, then that would be the same. Now let's look at these variations. Choose which ones are linear. Explain why the other ones aren't. Well, anyone's linear, it's because they have the exponents of 1. So this one, yes. Oh, yes, it's linear. This one has an exponent that's greater than 1. No. In fact, tell you that that's the shape of this one. Camel hump, in one sense, on one part of it. Okay, now here, this one is the 5th root of x to the 3rd, or 5th root of x, and all that 3 is out here. So either way could work as long as the 5s were there. Let's put the 5 in here and 5 there. Okay. Now this one, let's actually I look and see that these both y and the x have an exponent of 1, so it'll make a linear equation. Whoops, it's a -1. No. Yes. Okay, now this one, interesting. The y goes forever both ways. And in this case, then, it's a straight horizontal line, so it could be considered linear also. All right, now here, this one has an exponent of 2. It's going to be a parabola, something like that, and that's a no. Now on this one, let's take the x and bring it up to the main place where our society expects it to be. Okay, so it has an exponent of 1 right now. It's not going to have an exponent of -1. So we have this y equals 7 x minus 1 over 3. Okay, the x is the only thing that had to come up. Oh, but that -1 is supposed to be an exponent. Okay, so this is a no, because it's a -1 exponent. That's not a 1. All right. This one here is a repeat from this one. So do it on your own if you wish to. Make sure you understand why the other one is yes, a linear equation. Okay, now here, y equals 7 over 2 times x. The exponents are still the same. Therefore, it's nonlinear. This one, x equals -2, goes up and down constantly all that way. So it's still a straight line, so it's yes. And this one is not a straight line, because anytime you see the square root, it's going up and over something like that. Oh, no, so I don't know why I started writing yes. So no, it is not an example of a straight line. And I think that puts us in pretty good shape here. All right, I hope that helps, and thank you for listening and watching.